Hello.
Hi.
How's it going?
It's going good.
Going good.
Yeah.
Might look oddly very similar to how we looked last week.
Oh no, it's completely,
Completely different.
coincidental.
Definitely not like 15 minutes after we finished the last episode. You good?
I'm very good.
You ready?
Always ready.
I'm gonna go grab some information.
Mm-hmm.
You guys want to head over to yours?
You should have over
get,
mine.
Get going.
Get going.
Get going immediately. No hesitation now.
Hi, Gabe.
Hello.
You love it.
I do. It's pretty fun.
So now we know a little bit about classes.
We do.
A little bit. So let's apply that knowledge to our game. So this part might be a little shorter, but it is still very, very important to do.
Should I put this into my game sketch? So just replacing everything I did in the game sketch before?
Yeah, so he's what he is doing now is he's taking the solution from episode 3 and putting that into a sketch, an empty sketch.
What is all this?
And you should be able to hit play, and you should get the collision stuff going.
Yeah.
Mm-hmm.
Cool.
Okay.
Good to go.
Good to go. So let's go. Let's switch over to... And again, we're using a tool called Open Processing, openprocessing.org. If you have this, you can go to this website. You see a pretty little thing. If you scroll down a little bit, there's a thing called Create a Sketch. And what we're going to use is the solution from episode 3. And if you want a refresher, we ended up somewhere here where we have a box that can move around and it can collide into other boxes.
Whee!
That was a fun one. It was a very fun one. And a lot of code that we had to go into. There's a thing that we can see from the class episode. We have an X and Y standing alone here. We have a ship height and a ship width standing alone here. We have vertical and horizontal. We can group these.
Call it spaceship.
We could.
Call it something.
Yeah. It's our interpretation. That's where the design comes in. Here you have some logic with if you type a key, when you release a key, you have these functions regarding the collision and then the checking for the collision. To simplify this, and then we will add the collision later on in another episode. For now, the collision stuff is point inside box and is box inside box are going away.
Oh god.
They are going away.
So is point inside box and is box inside box?
Yes, you can delete
dead?
those. They are gone.
They're gone.
Mm-hmm. And inside of the draw function, for now, there will be nothing. It will all go away.
Oh, man.
It was maybe not visible on my end, but it is empty. We can add a clear, just so we don't get the little effect that happened a while ago. A while ago, but generally it's clear. So now when I hit play, there's nothing. Oh yeah, I found the solution to this. So what happens is if you scroll, so if you have enough code, the minimize thing would happen. If you control zoom until it's very tiny, no, the other way around, you'll see the dots at the corner. It's an odd solution, but here we go. So yeah, if you hit play, you will just get a blank slate. There we go.
It is blank.
Otherwise, this will be very similar. So if we look at what we have some coordinates, we have a height and width, we have some setup, we can ignore that for a bit. You can do a thing. There's a tiny arrow here next to the line. Boop.
It's gone.
You don't have to worry about
Don't
it.
even see it.
If you want to look at it later, you can do this. That's a little nice. And we have the key information. That's great. But this we need to abstract away. Because as you saw in episode 3, when we were doing the collision, when we created those functions that we just deleted, they took in 6 arguments. And that's not good enough. So we want to abstract this away. So how do you think this would be abstracted away? Gabe?
Create a class.
We create a class, that's correct. So what do we have? We have a ship.
We have a ship.
Mm-hmm.
We have an X and Y starting point.
Yeah.
We have horizontal and vertical.
Mm-hmm.
So this is Oh, what do these horizontal and vertical do? This is the movement, right?
Yes, this is the movement.
And then the ship width and height is how
Yeah.
big it is.
What do if I move these two together here? What do these represent?
The position, the spaceship.
Yeah, which is in actuality just a box, right?
Yeah, not actually spaceship. It's just a box.
It's just a box.
Yeah.
We added, what was it, episode 2? We had a little spaceship.
Yeah.
We might add it later again, but it's a box. So should we create a box?
We should.
Let's do that.
Nice.
So we can ignore the vertical and horizontal for a bit. And we can create a class called box. Simple as that. And as we see here above, they will take in, so these will have the 4 variables. Let's just call them x, and then the y, and then height and width. So a box is a grouping of those 4 variables. We would like to create a box in a very easy way when we knew a box. So we would like to create a constructor that sets those values. So a box, how many variables are in this constructor 4. Then? It was 4. And I'm going to introduce you to a new naming that I'm pretty used to that can help. So instead of saying int x, I will say ax, because it's the argument x. It's still just a name, just a variable called ax, little a, big X. So you have ay, you have a height, and a width. And that's it. So then in the function, you would like to set those values. How would you do that?
Oh man, I'm trying to remember back to like last episode.
Mm-hmm. We would like to say that x has a value. X should be what value?
X should be the x position.
Yeah, but what value does it take? What variable does it get the value from?
Right now?
Mm-hmm. Inside of this constructor. You would say x is equal to ax, yeah? Because someone is sending in this value, and we would like to just assign that value to x. And the same thing, that y is ay, height is a height, and width is a width. Great. Cool. Done. See ya. So now we have the box.
Yeah.
Same as before. It's a grouping of variables, and we have the constructor. Great. But what else did we do with these values here? So let's just look. Let's just go down. So did we do anything in setup with these values?
No.
Is it size? Is it just numbers? No. It had nothing to do with our box. Great. We have a function here called spaceship. It has a fill for a color.
But it has an x and y and ship width and ship height.
That has something to do with our box, right?
It does.
Yeah.
We need to give it ax and ay and a width and a height.
Or we can do a thing.
Uh-oh.
If we copy that rect thing, you can even just delete the spaceship function.
Oh man.
It is gone. But we have it copied. So, like we talked about last time, we have an interface. We would like that when someone uses a box, it makes sense that when you click a button or do a thing with box, that is the action. So if you press the gas pedal, the car goes forward. And if you have a box, if you would like to draw the box, that box then wants to appear on the screen, right? So let's create a function that draws the box. Would that function have to return anything?
Yes. No.
No? Okay.
No, it would.
Then it's a void. Let's call it draw. And we don't need to take in anything. Let's do this here for now, because in my copy buffer, I had the rectangle function. And the rectangle function just draws a rectangle at the x and y coordinates with the width and height. Okay?
why doesn't this need to return a value then? Doesn't it need to return whatever rectangle is?
No, because rectangle does all the work for us.
Oh. Okay, got it.
So rectangle is another function that's just made in the language.
Yeah.
So it uses x and y. If we scroll up, yep, that's x and y. Here we had ship width and ship height.
We need to change that.
Yeah, so let's call it just width and height, because that's the name of the variables we have. Okay. Should we just try it with that? Nothing
Sure.
else?
Do it.
Yeah. So here where vertical and horizontal is. Oh, you tried it immediately.
I got too fast. I got really excited.
He's very, very quick at this. So I would like to create a variable. Well, what would be the type of the variable?
So what are we trying to create now?
A box.
Box?
Yes. What should we call our box?
Spaceship.
Spaceship. And then we say spaceship is a new box. Let's go up to look at our constructor. It is the x and y coordinates. Let's give that 40 and 50 or something. And then the height and the width. And let's have that as before, 32 and 32. Great.
So on that new box.
So we now have a variable called spaceship, which is of the type box. And then if I go all the way down here, and I'm gonna the key typed, I'm gonna minimize those as well, just so we have less clutter on the screen.
Key typed and key released.
Sure, they're still there, just minimized. Here in draw, like we talked about last time about scope, box is in what we call the global scope. And here is another type of scoping, which is inner scoping. So this one knows about spaceship. So here I can say, not height, you had that copied, spaceship. And we would like to draw the spaceship. And to draw or call the function, that is a part of the class. So you just say dot to access it.
Box.
Draw. And that's it.
Really?
Yeah. And if we look at the code, so spaceship is of the type box. The type box has a function called draw. To access anything within the class, you say dot in this language. What we want to access is a function. How do you call a function? The name and the parentheses.
Which is this one.
Yeah. So if I hit play,
we have a box. He's back.
We're back to episode 1. We will fix this. Don't be that sad.
My box doesn't move anymore.
But look now. Imagine that someone would give you the class box. I say, I have designed this box. It is a wonderful box. It does all sorts of things.
It is my box.
It is my box. You can use it. And you would say, cool, I'm going to make a box and I'm going to call the box spaceship. So you say box is spaceship, new box, and then you give it some values. And then you think, I would like to draw the box on the screen. And then you just say spaceship.draw. That is the interface. When we would have a car, if I can imagine here, let's say I have a variable called car. If I say car and then push pedal, this works if someone has created that interface for me. If I say car.brake.
Bread.
Yeah, bread.
Car.bread.
Yeah. If you
car
want to
turns into bread.
If you want to bread the car, of course. So you see that the interface is, for example, a function call. A bad interface. So here this seems to be pretty nice. If we would say, oh yeah, we have the function draw, but you have to call it first, and then have to call some other thing, and then have to do these 2 other things, and then give it some value, and then do the third thing here. That wouldn't be a very nice interface to use.
Sounds complicated.
Yeah. Like with the transmission, like, no, just do it for me. When I press the pedal, I just want to go forward. I don't care how you're drawing it. If we go down here again, is there anything in this line of code that tells me how I'm drawing to the screen? And do I care? No. As an implementer of the box, I do care. But as a user of the box, I don't care.
I want to be a box user.
Box user.
Life sounds so much better.
It is simpler. It is simpler. Okay. We still don't have the movement, but we will fix that in a little bit.
Does that mean we can remove the stuff all the way at the top?
Yes. The X and Y in spaceship. Yes, we can delete those.
Dead.
Let me double check everything's working. Yes, our box is still there. Okay. Let me throw a wrench in your plans.
Oh man.
Yeah. So we have a
Not good
box.
with wrenches.
It is spaceship. Great. But we still have this vertical and horizontal thing. That's the movement of the box, right? Yeah.
It is.
It is. Let me see.
We had to put that there to make it so it wouldn't slide, right?
Yeah, there was a lot of quirks in the movement. But we've already solved that problem. That is in our key typed and key released. I would also want that to be in our box, right? To move a box around, that is also a nice interface. I have a box, I can draw it, but I also want to move the box. So let's do that. So let's focus on the key typed and key released.
Can bring them out from hiding.
We can bring them out from hiding. So the key typed and key released, for those who might not remember, these are functions within the language. So when someone presses a key, this function is just automatically called by the language. When someone releases a key, this function is automatically called by the language. And when they are called, this value here is set. So we can trust that this will always be the key that was typed. We can trust that this is the key that was released when this was called. Great. But I don't want this here. I want this in the box.
Inviting it to the party.
Yeah.
Let's do it.
So let's create a function.
Just do we call it something like void movement?
I'm going to call it is void, that is correct. On key typed. This is kind of standard when there's an event that happened. So when the key was typed. And I don't want to rely on that global key variable here, this one here. I want to give this, the function that we're making now, the key. I don't want this one to worry about some global key thing that lives in the system. So we're going to take in a variable of the type. So, and I want to do a thing right now. Yeah. How do you say this?
Char.
Okay. So this is the short of character. So many people would call it care. Others will call it char.
Char.
Yeah. I call it char.
Doesn't make any sense, but it's char.
Yeah.
Also doesn't make sense that character is pronounced character.
Exactly. Let's call that a key. Just with the same format here. And then just close it. And then create our little curly braces. And what we can do, literally, is we can take the guts of
rip them out.
Rip them out. I'll just cut it there. Cut.
Dead.
You missed that curly. I'm watching you. There we go. So it's key typed, and then just put them in there, and then maybe indent them in and make it a little
two curlies.
No, your indenting is off.
Oh, this is true.
So from line 26 and up. 26.
Oh, whoops. Yes.
There it is. There it is.
That's right.
But we still have the global key here.
Yeah.
I don't want that. I want this to be the value that we're checking. It's still the same logic, but it's just another variable. But here we have the horizontal and vertical, right? So then we have to take those and we can move them in. I can do a cut. I can move them in. And I don't want to set them the value 0 here. I want to have consistency. So I set them here in the constructor. So in the constructor at the end, I just say vertical is 0 and horizontal is 0. I think in the language you can set the values here, but for consistency, I want to do this because we will learn later on that you can actually make many of these. you can have many constructors. So, and it would depend on how you create them, which constructor you call. So that's kind of neat. So
Kind of
cool. So because we put the variables in the class, they are now accessible here. So a key is coming from the outside, and these are the horizontal and vertical are from within the class. Then we just do the same with this key is released. So I can create a function, void on key released. It would take in the same, so a character, a key. Yeah. And then I could just copy the guts. Boop. And same logic, but we replace key with a key.
My squiggly brackets are off again.
Yeah. And now your if is off at line 50. There you go. And yeah, when you paste, it seems to paste only the first line correctly, and the other lines one in. It's weird. Yeah, so a key is coming from the outside, the horizontal and vertical, same logic.
So now we can just delete all these too.
No.
No.
We still want the global functions, but we're not going to do much work here. The work we're going to do here is we can say spaceship, and this is the key typed. So can we just call that function on key typed, and then I just send in key.
Not a key?
No, because that is the name of the variable within this scope up here. On key type, that's the name here.
Yes.
The key is the global one.
Where is that one right now for me? Where's the global one?
It isn't created.
Okay.
It's invisible basically for you. But if we look at is key typed, we're just calling spaceship on key typed with the key. And on key typed is the logic that we had there before.
Yeah.
So there's no difference in actuality. We just moved it away.
Now we can just make as many boxes as we want with one line. We don't have to make multiple boxes.
There you go. You got it. You absolutely got it. So spaceship on key pressed. No, released, sorry. Yes, on key released. Key. Okay. Let me find out where I am in my notes. On key typed, on key released. Yes. Okay. In our old draw, we would have all this logic with collision. We're not going to have collision right now. We just want to go back to the movement. We're back to square one, basically. But
see what you did there. We'll be back to square two if we just duplicate it.
There you go. So we're not going to have the collision now, but we can add it later in because it will complicate the explanation of this idea. But we want the movement back. And the old movement was just to say x is equal to x plus whatever the horizontal movement was, defined by the key. And then y is equal to y plus whatever the vertical movement is. And that's still the same idea. It's now just going to be contained in the class and nowhere else. So I want to create one more function in box. And I want to call that function update.
This is in draw?
In the class at the top. Here. You can do it below the draw. Mm-hmm. And it does not take anything. And within this function, we're going to do our old movement. We can say x is equal to x plus horizontal, and y is equal to y plus vertical. Back to the old school here. No collision, no nothing. We have that. And yes. Okay. So now, if I go all the way to the bottom here, You go down to draw. We would like to draw the ship. If I hit play, for example, I will get the ship, but I can't move still. No. But if I say spaceship update, and I hit play, we're back.
What did that do?
We are back.
We're back.
So let's follow the flow, and let's only look at draw, nothing else. Let's just absolutely focus on draw. Let me even zoom in to emphasize on this. Just draw. Clear is made by the language. We don't care about that. It just clears the screen. Spaceship. What is that?
It's a spaceship.
What is the
drew.
Yeah? What is the type of spaceship?
It's a class.
What's the name of the class? That is
Box.
it's a box. So spaceship is of type box. So we have two of those, two functions. I would like to call update, and then I would like to draw. You'll see why in a bit I've separated these two. It's kind of there's a reason for that.
There's a reason for everything.
There's a reason for everything. So let's look at how we made spaceship. Let's find that up. Scrolly. Here it is. It was line 76 for me. There it is. 75 for you.
Oh. So aligned in our lines.
We're not aligned.
I made a space somewhere.
It's okay. It doesn't matter.
Is it though? Yeah. Anyway.
So we would like to create a variable.
Oops. Yes.
Called spaceship. The type of that variable is box. The value it will hold is a new box. It's not going to be some other box copied from somewhere else. And we will call the constructor, which takes in 4 variables. What those variables mean, we don't know yet. Just looking at this. So these were 4 numbers.
Big box.
See, he knows what he's doing. He knows what he's doing.
Changing numbers.
Yeah, I know. So let's look at the constructor. We're just following the flow. Here's the constructor. Takes in an x and a y, and a height and a width. You see it better on Gabe's end, but yeah. Okay, what does it do? So it's a class. It holds 6 values: x, y, height and width, and vertical and horizontal. And these are just numbers. It's the programmers who apply the meaning to it. So x is whatever the first argument is. That's called ax. Y is the second, height and width, and vertical and horizontal are defaulted to just some 0 value. Great. Then we come back here. So now we know what spaceship has as a value. Great. So now we have a spaceship. We know what that is. Then we're calling update on the spaceship. So what does that mean? Let's go. Let's find update.
Okay.
Update.
Got it now.
Yeah. Update is just doing the x plus horizontal, y vertical. It's the same logic. It's the same flow from episode 3. We just moved it. We moved it into the class.
Is update just a word you decided?
Yeah.
Anything?
It is
it's void. Move spaceship now.
Yes. Yeah. All names that we make are names that
Void get to the chopper.
Get to the chopper.
I don't know why that's what I thought of, but
that's fine. Names are made by us. And that's kind of part of the design is what functions we create and what names we give them and what actions they do. The design is there. So this is good old move around. It just moved.
Nice. Good old move.
We just moved the move. All right. So that was simple. The call to update is just the X and Y thing. Let's look at draw. Okay. Let's find that one. Here's draw. It's just called rect. Good old rect. Rectangle.
Just wrecked. It's just destroyed.
Absolutely wrecked this rect.
Yeah.
Rectangle wants an X and Y and a width and a height. We have those.
Yeah.
They are part of the class. So again, that's totally fine.
And it's assigned in the...
Correct. When we made the box,
yeah.
It was assigned there. Okay, great. We are happy there. Okay. And then it ends. Draw is over. We will go back and then someone will call draw again. It will clear the screen. It will call the update, which is the X and the Y movement. It will call draw, which is actually just calling the rectangle. We'll go back down. We call draw again, clear the screen, update, draw, And this is happening
60 times a second.
crisp 60 FPS, right?
144, please.
144, maybe next time. So wait, how can I move then? There was nothing in that said I could move, right? Well, that was from before the onKey typed and onKey released functions. When I press a key, this function is called.
And because we put all that stuff into box.
Yeah.
Or into spaceship.
Yeah. Correct. You were correct the first time.
Into box,
yeah.
Which we're calling spaceship.
One copy of it is called spaceship, yes. And that has a function called onKey typed and then key. So
now we've literally just turned everything into movement, the shape of the box, the color of the box.
It's all isolated.
All now just box.
Yes.
So we can create another one called box banana.
We could. Let's do one thing though. Okay. So this works. Let's say we're happy. Here's the class at the very top. Let's minimize this. And we can minimize setup as well. It doesn't matter much. Show me in this part of the code, we're creating a spaceship. When the key is typed, we call the onKey typed on the spaceship. When a key is released, we call the onKey released on the spaceship. When draw is called, we clear the screen, we call update, and we call draw. Where's the logic? Where's the entire system? Where's all this complexity that we have created?
It's nowhere. We just have the interface.
Yeah.
It's all in class.
Or as some people say, magic. But no, it's just hiding. That's why abstraction is sometimes called information hiding. And this is abstraction. This is absolutely, we're abstracting away complexity just so we can have a nice interface, and we can keep doing this forever. We can create another class.
We can keep creating magic forever.
Forever. And that's what we do. We're just creating some sort of abstraction that has hidden complexity within it. And then we're creating other abstractions which use previous abstractions again and again and again. That's why people say it's turtles all the way down. It's just, you just keep abstracting away. Even when you do this, and people are talking about numbers, that numbers are just bits, the zeros and ones. That is an abstraction. It's not really nice to look at zeros and ones. Therefore, you are allowed to represent zeros and ones as a number, as a natural number. That's nicer. But a 0 and 1 is also an abstraction. Do you know that? A 0 is, in some cases, I think it's below half a volt and above half a volt.
That's just confusing.
Or a magnetic direction on the old spinny plates, hard drives. Or do you see a reflection from the laser, or don't you see a reflection from the laser in CDs? Or it's
this is
time
beyond
travel.
me.
Like even the zeros and ones are an abstraction on top of some other system. And this just keeps on going forever. So when someone says we stand on top of giants, it's absolutely, and then we can create more and create more. And that's how stuff is made. We just keep on doing this for 5-6 years.
So can I create another box?
Should we do that?
Can I just put it, could it go here?
Let's make another box. We can end on that one. So let's make, I like the curiosity you just had here. You're like, I can make more.
I want to make more boxes.
Yeah, what should we call that one?
I call it banana.
Banana. I'm game. Banana.
I'm gonna make it bigger. It's gonna be a bigger box.
It's gonna be a bigger box in another location. What was it? 75 and 75. Okay. What we need to do is
change these two.
We need to duplicate.
Yes.
So we do it also to banana.
So it's banana.
Also banana. And then we call update on banana. And then we call draw on banana. And before you hit play, what's going to happen?
We're going to have two boxes.
And what's going to happen when you move?
Both of them are going to move. Oh, movement!
You are absolutely correct.
Boxes!
Yes.
It has a friend!
Do a thing.
Happy little box.
Do a thing for me.
Okay.
Duplicate banana update again. So you have two banana updates.
Oh, shit. But that's just going to put banana update on top of banana update.
No, and before you hit play, what's going to happen? you're going to call update twice. Look at the implementation of update. You might have to unhide the box. So what does update do?
Oh, it's going to move twice as fast? Oops. It's too... No, sorry, for science. Oops. Wee!
I like your wee.
Wee! I'm out.
Yeah. Peace out.
He's got to go places.
Yeah. He has stuff to do, right?
Turn left, go fast.
And now you see why it was important to move update away from...
I want to just go...
I'm out of here. Exactly. There you go. I like that. I think we should end on that one.
We should.
Yeah, this was a little shorter one because I just wanted to show you the implementation of this. Please try this out. Practice. Try adding things. Try, like Gabe is doing, creating a zoom. And next time we're also going to learn another new concept. It's not as hard to grasp as class. Class is kind of a big thing to grasp. That's why I wanted to break it into 2 bits. Thinking of banana, breaking a banana into 2 bits, but anyway.
Peel a banana.
Exactly. The next thing we're going to learn is, so you see here, if we wanted another box, you have to give it a name. But what if I want to have 1,000 boxes?
That's a lot of names.
And I want all of them to happen on key typed, and I want all of them to react on draw and whatever.
I have absolutely no idea. Don't know what you would do.
Until next time.
Sweet. I think so next stream will be Friday. For you watching the VOD of this, will be Friday the
23rd. Yes.
2 p.m. CET. Be back.
And then
stream.
The week after that, we will have a week off.
Yeah. It's like rest week.
Rest week, but
I think we'll still have a normal stream, but it just won't be Code School.
Yeah, we will have Ancon will have a stream. I might send you some more material to read if you want to do that. Or if you want to ask questions, I'll be on the Discord. We have a Discord server channel there called Code School. I might be there. You can yell at me if you want.
But otherwise, everything is the tool, the code, the GitHub, the
Yes.
fun stuff is all down in the description below.
So if you missed anything at the point or want to watch it again or pause, the solution is in the description. You can just copy that or use that as a reference. Or if something isn't working, you can check between the solution and what you have. And happy coding.
See you later.
Bye.